for this particular problem, in order to derive it, we need to actually ln both sides. It's kind of a new concept, another trick to your bag of, process to the bag of tricks you have. Because the reason you have to ln both sides, basically, x to an x power, the only way you can derive this is if it's like a number to an x power. Since there's x's in both spots, you cannot simply derive it. The point of this is when you derive this, hopefully you know that's u prime over u, so that's going to be y prime over y. This one is going to be, well, we have to derive the side still. We're going to derive it, but do you understand we first want to do this? Do you see I kind of goofed it up. I derived this side, but this side don't have to move it first before I derive it. Okay. So if I would have just moved this up, anyways, I move this in front. That's the whole point of the ln, because I can move that in front, and now I can derive this. So this is going to be y prime over y. This one is going to be a product rule. So the derivative of x minus 1 is 1 times ln x plus, leave the x minus 1, and the derivative of ln x is 1 over x. Okay, so again, we derived both sides, but this one we had to move in front first. Now, I can simplify this, and I have to multiply both sides by y, because I got to get y prime by itself. So I now have y prime equals, this is going to be ln x plus x minus 1 over x, all of that times, what's y? That's y. See it? Y equals. You could leave it like that on the test. Okay. I don't want to deal with getting x's on the bottom and so forth. This is good enough. A lot of people will forget to plug y back in. They'll just leave the letter y. But since we had y from the original, you could plug it back in and get everything in terms of x's. Okay. It's kind of like you made it into an implicit problem, but in your answer you still want to be y prime equals all by itself.